We are here. We are live. And as soon as I remove this background, there we go. All right. So we're here. It's pretty exciting. The Constellation Hackathon has officially ended. Out of the 700 applicants, it got narrowed down to about 30-something. And I'm here today with Bruno, who was one of the developers who submitted not one, but 2 submissions to the Metagraph Hackathon. And we're going to dive into both of these applications. The first one that we're going to be discussing is his YubiKey implementation. And then the next application we're going to dive into is his decentralized science Metagraph. So for those of you who might not be aware, Bruno, you've been pretty active in the community, in Telegram and Discord. But for those people who are not as into the Constellation community or ecosystem, why don't you tell us a little bit about yourself and how you found Constellation, and what about this ecosystem really intrigues you?
Yeah. So first of all, thanks for having me here. And it's always a good question. What do you even do? So I guess it mostly started back in 2017 when I've written my first smart contract on Ethereum, and it just blew my mind how you can program a software that runs in the internet and nobody can stop it. And since then, I really dug into this whole crypto economics thing and tried to figure out what this is all about. And then over time, I started algorithmic trading at some point, and I still do it actually. And then over Constellation Network, like maybe 2 years ago, stuck with me. I first read about it, and for some reason, after 5 minutes of reading into it, I was like, yeah, that's it. That's how you should format data, I guess. And it's fun. For some reason, it really is close to how the algorithmic trading systems of mine handle data. So it kind of feels that there's some like fundamental truth to the system that makes it able to adapt to all kinds of data pretty much. And then I was really enlightened to see this hackathon, because now finally it's time to build metagraphs on Constellation and put them live. And for the last 2 years, I always thought about what you could build with Constellation, but I always was in kind of design mode, right? But over the recent month, I've built my first metagraph in a hackathon a few months ago. It wasn't complete; it was just a 2-day hackathon. But then this Constellation hackathon, multiple weeks, I finally pushed through and have a metagraph running with one of the use cases I thought about over the last years by now. I'm really glad I pushed through, and it was a very, very nice experience. From all the hackathons I've been at, you really got a lot of support here, and it's as always, it blew my mind, because I always say, it's you need to build on a ledger to really understand how it works. And with Constellation Network, the same thing, just as 2017 Ethereum blew my mind. It's just interesting thing to program. Yeah.
So getting into your first application here, the YubiKey. Tell us like how did this come about? Like how did you decide that you should do this on top of your other application that we're going to dive into a little bit later?
So a few weeks ago, maybe 2 months ago, I sat down with a friend. I told him about Constellation Network, and pretty much his first question was, has it hardware wallet support? And I was like, yeah, Ledger takes some time, but there's a BIFI, maybe you have one, maybe not. But at that time, I had a YubiKey, just like this in my wallet. We were sitting at a bar, and I was showing it to him. I was like, yeah, I guess if this thing supports the correct encryption curves, then we could build a a hardware wallet out of it, and it would be comfortable as well. And at that point, I said to him, I have to check whether it supports, the right encryption curves. But then a few days later, I checked, and I was like, yeah, damn, wait, let's just build it for the hackathon. And that's how it came to be.
Yeah, and how, just for those people that might be interested in how complicated or complex, it would be to build an application like this, can you talk about how long it took you? Because I know that I helped the BitFi guys. Well, I didn't help them build it. I just pointed them in the right direction. So here's your GitHub for the YubiKey implementation. And with the BitFi guys, they reached out to me and they wanted to know where it was on Constellation's GitHub repo, where the Stargazer stuff was, so they could implement their hardware wallet. So approximately how long did it take you to go from concept to working application?
Yeah, that's an interesting question, actually, because I was surprised myself. So first took me maybe a couple of hours to chat with ChatGPT about what the best architecture of this is overall, because I knew that it's important to have the signature go through Stargazer, because then automatically all of the dApps that connect with Stargazer can be used from a YubiKey wallet. But then the obvious problem is you have a YubiKey that's being plugged into your computer. How do you make it communicate? So then I found out that you can write a native host software that registers with the browser and do the communication with that. And then for the next 3 days, I dug into the Stargazer code base. I reverse engineered BitFi. A ledger is already in there, by the way. And I learned basically from their code, and I reproduced the same code for the YubiKey wallet. And then maybe another 3 days actually generating the signature on the key, like what you see on screen here, like figuring out these specific APDU commands. And because I first tried to GPG, but then I figured that you can't, sign raw data through it. And, it took maybe then another 2 or 3 days to debug this whole pipeline, because there were easily 5, 6, 7 mistakes and some weird encodings in there that I had to debug, and, threw my head against the wall. But yeah, in total, maybe a week and a half. And this was full-time hacking, of course. But yeah. But
that's pretty impressive to go from concept to running application in under 2 weeks, and with the help of AI, it's going to be pretty impressive going forward, just to see how many people like yourself that have an idea, but with the help of AI can actually take your idea to product. So I think you have a YubiKey right now. Can you show people that, maybe those of you people who don't know what it is and how it works?
Yeah. So basically, so there are different form factors of a YubiKey. The typical USB A1, USB C types, or these little nano ones, which you can just plug in the laptop and have it on your laptop all the time, right? And basically, all of these keys, they implement a open PGP module, which is a standard to format the communication between a signing device and a computer. So basically, the YubiKey wallet, it hooks into this open PGP and extracts public keys. And so yeah, ultimately, to use this as a Stargazer wallet, you have to load a private key on this YubiKey, and then you can connect it to Stargazer. How about we just show it how it works?
Yeah, let's do it. I mean, live demo.
All right. So
what could possibly go wrong?
Tried this a lot of times during the hackathon. Nothing can go wrong at this point. So So as you see, there's a YubiKey wallet connected, and I have a Stargazer wallet here in my browser. It's the modified Stargazer I developed during the hackathon, right? So, so there's a new, it's a fresh wallet. Like by default, you have to set up a, like your typical mnemonic phrase. But we don't care about that, right? We want the YubiKey wallet here. So you go under settings and wallets. You click import wallet, Constellation, and then there is a hardware wallet option here, right? And let's see, click on next. And this one, this page then basically goes over the importance of installing the YubiKey bridge, that software I talked about that sits between the browser extension and your USB device and does a communication that needs to be installed on your device. This links to pretty much an install script. Currently, a hackathon style, you have to run a script to install it. This one, but once you do it, the extension can communicate with the YubiKey, and then you click on connect YubiKey, and right now you can see the YubiKey. It lighted up here, right? So there's a little like green light flashing.
Yeah, I can see
on the key. Yeah, and that is because the extension now called up the YubiKey and extracted the public key from the YubiKey, and from that public key, the address right here on the screen is extracted. So, can you here? So now the Stargazer wallet has generated the address, right?
Okay.
And we just select that, click import, and now we have that address which sits on the key. We have it imported in our Stargazer. Let's see. Yes. So actually, it's a fresh address, right? So I just newly, when we started here, I just newly set up this YubiKey with a new private key. So no assets on the.
There we go. So I got 100 DAG here.
All right. Yeah. How about you send me some?
All right. So I'm going to scan the QR code. Live demo here. What could go wrong? All right. And again, what the heck? It's funny because we did this like right beforehand, and there was no mix-ups. All right, let me try this again. I'll send 10 DAG. I don't know. This is the problem with doing demos. All right, it's probably something on my end. Hold on, let me try it again. Okay, so again, we got 100 DAG. I'm gonna scan the QR code, which I got, and all right, there we go. Transaction is on the way.
Nice.
I don't know exactly what happened, but you can see here the transaction is spinning there. Yeah, there we go. 100 DAG, and I'm sending you 10. So I should have 90 DAG, and you in your key should have 10. if my math is correct.
Indeed. So yeah, we can see it here.
So
10 DAG.
bam, there it is.
There we go. Let's see. So this was the transaction. Let's just send it back to you, I guess.
Okay.
And see how the signing works.
Sending me back my 10 DAG. Minus the fee that I paid, because I paid the node operators. The fee there is optional. But yeah, so we're going to reverse the transaction. So I should have 99 DAG again, if my math is correct.
All right, now comes the important part. We have.
Because I have 89 DAG.
We have 10 DAGs on this YubiKey. We just received it, right? So this address got generated from the YubiKey, and you can see here on the Stargazer in my browser, the 10 DAG just got received, right? And yeah, it's still an interesting feeling to hold DAG on a YubiKey. But in any case, right here, this is your address, I assume, where I just received the 10 DAG from. I'll just send you all of it back, right? And we click send. Yeah, looks good. Yeah. And now we see this screen, and basically I have to enter my PIN code first into this view, right? And as I enter my PIN code,
so it's like an added security feature.
Exactly. So basically, the YubiKey, they always say has 3 features. You have to have something physically in your hand. You have to know your PIN, and you have to be present in the room. Because if I type in my PIN here, click sign, look, the YubiKey lights up and it waits for me to physically touch the key. And only as I touch the key, look, only as I touch the key, this transaction goes through. So now the transaction is underway. It got signed by the YubiKey on the YubiKey. And yeah, let's check that on mainnet.
Yeah, and it only signed the transaction after you touched it. So that is like an added security benefit.
Exactly. And here we see a few seconds ago, transaction, 10 DAG from the YubiKey wallet back to your wallet. And there we have it, folks. To put it in your words.
Bam, and then there it is. So 99 DAG is back in my wallet. There it is. And the reason why there's 99 is because I paid the fee, which is optional when you're sending it. You don't have to. DAG is a feeless network, but I decided to tip the node operators for this demo. Yeah, that's great, man. That's super exciting. Like, I would definitely use that, and I know that there's a lot of people that want a hardware wallet application. Is there an estimated time on when this could go outside of the hackathon submission? Because this isn't live, correct? Like, I mean, we just did this live, but I couldn't go buy a YubiKey and implement this, right?
Yeah, that's a good question. So before I was even able to import the wallet, I had to prepare the private key. Right, this is something that I didn't do in the hackathon, like some nice user interface where you just plug in your key, you click generate, you have a new key. Like, it's all command line right now. for now. And like some testing definitely is required on other platforms, Mac OS, which I haven't done in the hackathon either. Yeah, we'll see. Like I assume like to have it really production ready, because it's critical infrastructure. We shouldn't just hack something quick and release it. Like we should really test it. But I would target like Q1 next year if we like build everything out evenly. And then optionally, because right now I only implemented the browser extension Stargazer, but really, USB-C, for example, can be used for phones, or this huge one actually has NFC in it. So you just have to hold it to the back of your phone while you touch it, and in theory, can use a YubiKey even on your mobile phone to sign, a DAC transaction. So that requires us to change the Stargazer mobile app accordingly. And in a way, it's the same code base. So much of the work it probably has already been done that can just be natively compiled. But like it's definitely some work to do still before this is like a nice user experience as anybody would expect. But the core of it works. Like you can, if you want, you can clone the repo today, install the bridge on your machine, have the modified Stargazer wallet, compiled on your machine, load it into your browser, and use it today. Like that's available, and it works. Everything else is just sugar on top to make it easily usable for non-technical people.
Yeah, well, I mean that's pretty exciting. I mean that anybody, if they wanted to, could just take it upon themselves and implement this application, because you did all the legwork. It's on GitHub, and people can just copy your example and implement that. Yeah, that's super cool. Now getting into your other application here. Let's dive into the decentralized science application here. This is a little bit heavier of a metagraph, and there could be lots of examples of lots of applications that could use something like this. Like you could use it for climate science, or medical, like healthcare, potentially. So talk a little bit about this application. Like what exactly does it do, and how did you get the idea for this?
Yeah, so basically I carry around roughly this idea for multiple years for me right now. So it all started back in my algorithmic trading days, actually. So where, back in the days, 2017, I just, programmed something like freestyle, kind of, like being young. But I always find this problem of algorithmic trading a very, very interesting use case, because it's a super general decision-making problem, right? Like you observe the world. Exactly. You observe the world, and you have to make your best decision all the time, right? And it's a very abstract problem in a way. So this pushed me, after more years of trading power markets and crypto markets, into this direction of structured causal models, because as I found, structured causal models are a nice mathematical framework to formalize, like, essentially cause effect relationships that sit in not just the markets but everywhere in the physical world as well, right? And this was really the eye-opening moments for us, where ultimately, these models, ultimately it's a graph. This one is literally a DAG, DAG. So you might see why I'm so obsessed with Constellation Network and implementing causal graphs, causal networks on Constellation, because the data structure of Constellation is so similar to structured causal models. So in this hackathon, I really focused on finding the mathematical definition of a structured causal model that is a valid structured causal model, but is executable on Constellation and can use observations from Constellation, other metagraphs on Constellation Network. So let's skip to. So yeah, I mean, like the long term, like my personal goal over the years kind of came to be to make money obsolete, right? And it may sound like a little bit like too far out, and I'm not sure how far out it is, but it's probably some time out. But I feel like once you can reason through reality algorithmically, then you can address and weight many different kinds of costs and values with each other, non-fungible kinds of values, and you're not required to aggregate everything up into a single scalar value anymore, right? As money does. So DeCiNet really is here is a kind of let's say I always call it the epistemic process, right? We're discovering models of reality through this crowdsourced process. But once we have those models, automatic causal reasoning with the do calculus, it's like a mathematical tool to reason with these models, allows us to go after a bunch of use cases. This, for example, right here, auto write. I did this for a earlier hackathon where a ride-sharing session is coordinated through structured causal models, where you can see that it's just belief action pairs. The user does an action of ordering a ride, right? Creates a message. The recipient, the driver, gets that message, integrates it into his belief. Think about it as a constellation node. He receives this message, integrates into his belief, and based on that information, he does an action, which is accepting the ride, right? Signing the deal, right? Which is sent back to the user, and that message, once again, is integrated into his belief, as in his constellation node. And once he received that bit of information, he does something in the physical world. And what he does when he receives that confirmation is that he walks to the pickup spot, right, that they agreed on. And simultaneously, the driver drives to the pickup spot, right? So at this moment in time, two persons are coordinating in the physical world, right? And the model, assuming it models how humans move through space and how cars move through space, the model can then algorithmically derive that in 5 minutes, the user is expected to be at the pickup spot, right? Or the driver is expected to be at the pickup spot in 10 minutes, let's say, right? We can look forward in time, essentially. We expect the user and driver to be there. And then once time catches up, we measure, let's say, the GPS of the user's phone or the GPS of the driver's car, and we integrate that observation in the model, and we see whether expectations are aligned or not, right? So you see kind of how this reasoning helps us to coordinate through time and space. And what you're showing here right now, it's more like the specifics of the hackathon. So let's go for this one.
Oh, sorry.
Let's see. Yeah.
I'll let you pick the best one, but I mean, this could apply. Like it could actually potentially predict how like a road closure would affect the traffic flow, and the app itself could proactively reroute drivers or even the passenger potentially.
Exactly. Yeah, it's a good way to think about this routing or navigation through space. But the one big difficulty here is that you need a good model describing reality to be able to reason through it mechanically. Like there are tools to do calculus to reason through it, but it requires you to explicate your causal assumptions. And you explicate those causal assumptions as a structured causal model. And DeSciNet really is a network that creates this competition to define the causal model that best describes our physical world, or everything we care about in that world. Kind of as a pre-problem to then use the reasoning in many other business problems. So, in the typical literature of causal models, this is how you would define a causal model. It's taken from a book, one of my most important books I've read, Causality, from Judea Pearl. Right, everything is in there. And actually, the word DAG, in there is like probably hundreds of times, because most of these structured causal models are actually DAGs. So I always find it funny to read it. But but in any case, in this book there's this like general definition here, but there's this one problem that that data in Constellation is discrete, right? We have exact measurements of arbitrary data types at arbitrary points in time. So the difficulty for DeSciNet really is how to adjust this like super general formula to Constellation. So ultimately, what this is, U is a set of background variables, essentially the data you observe that you don't know where it comes from really in your model. Then there is V, which is all the variables you have an understanding of, right? The variables that you explicate your assumptions of. And F essentially are the equations that are mapped to V. And ultimately, the equations that make that define variables in V, they may reference other variables. So at the end, you really get to this DAG, right? Like here, A, B, C, D. Essentially 4 variables in a model, and they all depend on each other in some way. And that's really what a causal model is. And now DeSciNet, the models in DeSciNet look like this, where it's a mathematical like way to basically just say the same thing, except that time is kind of like discretized into snapshots, and that these equations really are arbitrary scalar expressions, right? So ultimately, you arrive at a point where you can upload a model that looks like this, right? You see it here that this is a model that references variables from a Constellation Network metagraph and puts it into a model as exogenous variables, like the background variables that we don't model, that you just receive data streams of. And then these longitude-latitude streams are used in the internal variables when we explicate the causal assumptions as equations. And these equations are the causal understanding of the world that DeSciNet really tries to extract out of the wisdom of the crowd, pretty much, right? Because we have all of these data streams in Constellation, and over the next years there will be way more data streams than we have currently live, right? And so we have all of this data, but there's so much more insight we could get out of it if we can sort it into a model of the world and then reason through those models with this data. So these equations in this case here, they model how humans walk through space. Because what you see here, like the first equation, it just takes the latest measurement of a longitude variable, right? And adds a random noise to it, expecting that humans, in a short amount of time, walk a certain distance, but very, very, it's very, very unlikely for a human to walk thousands of kilometers in a short amount of time, right? So in a way, it models that the human must be close to the last measurement if it was taken, recently. And that's just an assumption, right? That's a causal assumption. It doesn't say anything that this is how humans actually move through space, but we can model it as an causal model, upload it to the network, connect it with the correct measurements, longitude, latitudes, right? And test it, basically. So in this case, longitude, latitude are Google timeline. It's Google timeline, basically. Every few minutes or so, Google captures where I am and stores it for me. And you can extract this data, and then you have the stream of measurements, right? And here, I just ran that simple model on a day of my timeline, right? And this graph down here is essentially showing the surprise. And what surprise is pretty much the divergence of what the model expected and what was actually measured later in the data. And when you see a high surprise, it means that there's something that the model hasn't modeled correctly, right? If you have a low surprise, that means the model predicted everything perfectly, right? And this bar chart right here, it goes left through time, and it just shows the total surprise over all measurements. And you see in the beginning, the first few hours, the total surprise rose very little. And that might be because I stayed at a point for a few hours and haven't moved much, right? So according to the model, everything as expected. Humans don't move long distances in a short amount of time, right? But then surprise jumped a little bit, and then an hour later, surprise for a few hours just skyrocketed. And that is because during these 2-3 hours, I was on a flight to Rome, right? And the model just did not incorporate the fact that humans are able to board an airplane and go multiple hundreds of kilometers per hour, right? So just it just didn't expect that. So the model was wrong on predicting where I was, or it considered as very unlikely. And that's really where the global competition comes in then, because this model, it leaves out so much facts of reality. Sure, humans can walk, but they can also take a bike, take a plane, take a car, take a train, whatnot, surf or whatever, right? So now it's up to other researchers to figure out how to make the model better reflect reality so that this graph stays low, right? That we're not surprised anymore about something happening or not happening. And this really is, this is really how we get to good models, I guess, by making everybody participate and having an economic system that sits between all of us to select the models objectively, and then reward those authors who invented the models that are actually becoming the consensus model, right? And the cool thing is, because there is this general framework for causation that can be adjusted to Constellation Network in general, we also can have a general algorithm that quantifies the surprise of models, and also a general token economy that is able to pay rewards for all domains there are. It's not tied to a domain. Causal reasoning applies to everything pretty much. Physical space, for me, it's algorithmic trading. I use causal models to trade algorithmically on chain. But I really want to use algorithmic trading. I really want to use the same algorithm with causal reasoning to coordinate humans and build a better economy, right? So that's really the goalpost there, as far as I'm concerned. And DeSciNet is the first step to to get to the models. And once we have the models, we can reason algorithmically, which takes a lot of load off humans, right? Especially in organizations which are many millions or billions of people. Reasoning coherently in those large organizations is difficult for individual humans to get correct.
Yeah, so you could potentially use this model from different metagraphs, correct? Like you could have different data streams from other metagraphs potentially, and their real world data in implementing this model, correct?
Yeah, so exactly. That's what's the whole point of the DeCiNet Metagraph, this hackathon. It's one metagraph that imports data from possibly all other metagraphs, from other metagraphs. And DeCiNet then, attaches a model to all of these data streams, multiple models, and selects the one model that best fits the data. Whatever data it is about.
Yeah. And is this application that you like? Have you thought about using a token for this, like attached to this framework? Like how would that work? How would the whatever it would be called, the DeSa token, I guess, maybe.
Yeah. I thought about this. So I tried to have something like this in the hackathon, but I just wasn't running out of time. But I definitely thought about it. So basically, I call it competition, but there needs to be some objective. Just surprise minimization is not enough of an objective. It's good enough to have a selection algorithm, but not good enough as an objective on what to surprise minimize. And this is where the user comes in, because users or businesses, like whoever essentially cares about predictions, they usually know what they care about, right? I care about like predicting that I'm not hungry over the next few days, that I can, get back home safely, that my flight is on time, predicting when my when my ride share will arrive, something like that. So essentially, uh, we need a token economy, I would say, that allows us to collectively stake on certain outcomes with an economic stake, pretty much. That then, as a network, essentially um, filters for the variables that are important to predict, and then steer all of our causal modeling compute towards those variables. So on the one hand, there are consumers who want to have certain variables predicted, right? They stake on those variables. And on the other hand, there are modelers who take those stakes as requests, let's say, right? And they are incentivized to create models that explain the requested variables the user staked on, right? And then there's this competition going on of many people trying to figure out how to model the requested variables. And the network then, once you upload a causal model, it needs a lot of compute to verify these models, because ultimately you need to sample predictions in these models and compare it against the observations of the input metagraphs. And this requires a lot of compute. So there is this this token sink, which is staken on outcomes, but also the token emission, which is uploading models and having these models sampled, right? And as long as enough people want to have variables predicted that are not yet predicted, they get the token to set out a bounty. And the network essentially, as a service, gets these models more correct, right? Being paid by the token. So that would be my vision for causal modeling, crowdsourced causal modeling, as a standalone token economy, at least.
Yeah, the applications here, I mean, especially for the builders, I think is pretty beneficial, because that's something that that I've tried to hammer across the broader community of what Constellation is, and the tooling and application that it provides actually for builders. Because people, I think they seem to forget that these metagraphs are layer one networks. They're entire networks, entire economies of their own, and a tooling like this would benefit those people by having better modeling, and that in turn would improve and benefit the user. So yeah, I mean, so what's the next steps for your application?
So the first of all, it needs a lot more testing, edge cases, some security issues, because ultimately users upload arbitrary code. So it's super important that this arbitrary code, when it gets compiled down to executable code, is not cannot be used to exploit other nodes, right? So we need to run it in special containers, and hardening the runtime, implementing the causal reasoning part of it, because currently only I implemented a sampling part to test the surprise models. But assuming we have a good model, we also want to use those models to reason counterfactually. Essentially, what if we do that? What will happen, right? This is something to implement next. I'm currently I'm just juggling around like which use cases to pursue first. For me, algorithmic trading always is the validation use case, because it's a super general decision making problem, and ultimately you just substitute the models for models of crypto exchanges and blockchains, right? And your values are what you want, which is an increasing balance of low risk, right? And this is my my validation project. Once that runs to my satisfaction, uh, you know all of the insights, essentially the core algorithm, equally applies to DeSciNet as a model sampler, but then further also AST network is what I like to call it, which uses structured causal models for social coordination and really pursues the vision of a non-monetary economy where we white essentially action and effect with each other, and we don't put a price tag on it, if that makes sense.
Yeah. So where's the best way for people to just learn more about what you're doing, or are you just gonna continue developing this until it's a little bit more scoped out?
That's a good question. So I guess a good entry of the vision behind it is a light paper I've wrote last year-ish, where, one second, I have to, right. Here, it's on my screen right now. We can roughly go through it. And this is specifically for Ask Network. Essentially assuming good models come out of DeSciNet, how we want to use these models. And it goes over, initially, essentially this question, I do this if you do that, and algorithmically answering, how we want it, what we can do, and what we will do, right? And these three questions are enough to answer what we could do so we like it in the future, basically, right? So I kind of like do some like wordplay here, but actually implement it abstractly enough in a network. I go over the economics, how coordination markets evolve. I do this, I do that kind of things, conditional actions, and touch on the tokenomics, and mention HTTP down here, by the way. So I guess this would be a good starting point, where just everything is written in plain English from top to bottom. But this is, I tried to put my feet into developing this over the last like a year or two. But I figured it's super important to have the core algorithm solid first. And this is the most important thing, which is my sole focus right now, apart from these hackathons on the side. So there is Rabot Crypto, basically. That's the autonomous trading firm. Where's my most of my focus right now. And essentially, it's just a tokenization of the algorithm when applied to algorithmic trading. And it's a company that's registered in Germany, like actually registered, and it has a token that currently lives on Ethereum. And it's basically anybody can buy a stake in this algorithmic trading company. Here we started to make some of our numbers public. For example, all stakeholders. Some of them are in actual shares. Others are in the token, right? And they equally receive reward from trading proceeds. So next up, what we already are implementing, is to do all of the accounting as a metagraph, pretty much. Because you can imagine that all of these individual domains that we trade in, different blockchains, different exchanges, different token economies, they all, deep down are their own metagraphs with the causal model attached, right? And so what we do right now is to essentially continue developing all of our domain models and make it a metagraph so that all of the accounting of this proprietary trading firm can get published on Constellation Network, right? Also we see how we can transfer like the Ethereum token, how to make it more interactive through Constellation, right? Because fee less network, more usable. This is my main construction site here, let's say, but only until the core reasoning algorithm runs with us, because at that point the company doesn't need any employees anymore. In fact, it doesn't even have employees by now anymore. It's just a company that's registered with an on-share profit share that hires computers to do computations and interact with the crypto markets, pretty much. And it's doing this through a generalized causal reasoning algorithm where you just put in a model from DeCiNet, for example, right? And your values that your balance should go up, and out comes the realized return of your trading decisions, which are distributed to the token holders, right? And once this runs, the obvious next step is to get rid of money. So this is where Ask Network then comes in, right? And this is where we can execute on this like light paper vision, because we have the causal reasoning algorithm. We now just need to reinvent the economy to be a non-monetary one. It's a lot of work, but that's the plan.
No, I mean, this is this is pretty exciting stuff. I mean, it's definitely high level stuff, when you're talking about causal models and stuff. But for the builders, for the people that are building these application specific networks, this is really cool stuff, and the end user is, eventually going to benefit from having stuff like this. I mean, this application that you've built, this DecenTrader, actually creates new ways for people to build models collaboratively, right? It allows users and these causal models to improve these predictions over time. And so, like as you were pointing out in the economy, it could model market trends and optimize policies, right? I mean, this system could completely revolutionize how we have predictive outcomes, and all of this is transparent, which is great.
Exactly. Yeah. So DeSciNet really extracts the causal modeling process, and it leaves how you use these causal models open-ended, because there's pretty much an open-ended range of applications of algorithmic causal reasoning. DeSciNet is just about finding the right models, because you need the correct causal assumptions in the first place.
Well, yeah. I mean, it's just my mind is blown a little bit. Just because it's crazy that all of this stuff is happening, and people aren't even aware of it, right? Like it wasn't until just a couple of days ago when the hackathon stuff went live with the final people that made it through the bar, right? And I was sifting through all the submissions to find out the stuff that I thought was interesting and had value. And it was crazy, all these cool and unique things. Some of these people weren't aware of Constellation before the hackathon, but what's really neat to me is beyond that, and there's other hackathon submissions that were pretty cool. Like there was one of a guy using you're driving, so you're filming your driving data, and you can upload it to different AI models to help predict and achieve better autonomous driving, right? Like that's pretty cool. But I don't think that guy was really aware of Constellation before the hackathon. But then you have people like you that have maybe had this idea on the back burner and just were waiting for an opportunity to implement your idea, because it wasn't until just recently where Constellation's network had the ability for people to deploy their idea and bring it to life. And so this is pretty exciting. So we've got two ideas that could potentially go live not too far from now, right? Especially your the YubiKey implementation. I mean, that could go live pretty quick, and somebody else could maybe take the idea that you implemented with this YubiKey application and implement it in something else, right? Because all of this stuff is open source.
Exactly. Yeah. The YubiKey wallet works, and DeCiNet, extracted, as I said, the sub problem that is input to many of the solutions for other reasoning problems, pretty much. And locally, the algorithm worked before. Well, actually, I implemented it during the hackathon in another hackathon, surprisingly enough, as not a Metagraph. And then in the last weeks of the Constellation, I added the Metagraph part to it. It's developing at a rapid speed for sure, and I'm really happy that this gets together now, and I'm really looking forward. Like this year, Constellation, the team shipped a lot. I think next year the community will ship a lot, and very, very exciting times for sure.
Yeah. And I guess as we go out and end this, I mean that's a good thing that you pointed out that gets missed a lot. Like your application initially started in another area. And that just shows that this Metagraph technology, you can implement your data from any existing model. So this, anybody that has a product that's already live right now, you could implement distributed ledger technology into your application. And there's tons of different ways that you could benefit from this, aside from the transparency and the security aspect of it. You've got the whole community aspect of it, especially when you implement a token to it. And they have the new delegated staking that's coming out early next year, which I think is going to completely transform this whole entire space. I mean, you could essentially launch your application with zero funds, basically, because you're essentially crowdsourcing your idea. I mean, if your idea is interesting enough to the community, they could just delegate their tokens to your idea. And as a developer, that to me seems like pretty good incentivization. Not only that, but as a developer, the other thing that's great about this network is not only can you integrate your existing structure right onto a Metagraph, but you can start earning rewards right from day one because you're a validator on your own network. So that's further incentivization to build on this network. So yeah, I think you're right. I think next year is going to be really, really exciting for this network. Especially Ben put out a piece the other day about they're going to be implementing a low code, no code option. And that again is going to further open up the floodgates for people like yourself to just implement applications with a couple clicks potentially. It could even open the door for somebody like me who has absolutely zero coding experience, but I have a pretty good fundamental understanding of ideas and how things could work. So that'll be really interesting to see how much more traction gets put out once this low code, no code option gets implemented. But man, I appreciate your time, and I'm really looking forward to seeing more of these developments from your applications. And anytime you have an update, I'd be happy to have you on again.
Yeah, for sure. I'll let you know. Thank you for having me.
Yeah. All right, everybody, take it easy.